Hello viewers, welcome back to my channel. So let's start today's topic. We have already discussed alphabet, string, language, and what are the operations we can perform on strings and what are the operations we can perform on languages. Okay, so let's see a few examples. Okay, so what are the operations we can perform on string? We have different operations like concatenation, transpose, and palindrome. Okay, let's see here how we can perform that operations through an example. Okay, consider the string x is equal to 110 and y equal to 0110. Then find. So the first one is concatenation. So means we need to append these two strings. So what's the answer for this? X is 110, okay, and the y is 0110. So that's the concatenation of x, y. That's the answer for the first question. Next question, yx. Y is 0110 and append with the x after y. So that is 110. Okay. Next, x square. What do you mean by x square? So that is x is followed by x. Okay. So right. Then how to... So we need to append the same expression together. So which is 110 and then 110. Okay. Next one is epsilon y. Epsilon is an empty string. Okay. So empty string then followed by this 0110 means what? So we will get the same expression again, 0110. Okay. So if you write epsilon here or not, it doesn't matter. Okay. That's the operation which we are going to perform on this string. Okay, and next we will see our next question. So let's see here. Describe the following language over the input set a equal to ab. So language L1 is equal to ab or ab square. So we need to define this language. So how to define L we can define as, so we have all the strings, whatever the strings here we have, all the strings have letter A and followed by any number of B's, right? So how to write this one? It consists of all the strings defined as, L1 is defined as consist letter A. Okay, so letter A is followed by any number of B's. Any number of B's means sometimes we have 0 B's, 1 B, so on. Okay, but A is common among all the strings. Okay, so L1 is defined as it consists of, or you can say it consists of, or L1 is defined as each string has a letter A followed by any number of B's. Okay, and that's the definition. And then we will see L2 is equal to A1, A power n, B power n, and n should be greater than or equal to 1. So how to say this one? So now L2 consists of all the strings we have. So here n is greater than or equal to 1 means n can be any number. All the strings having equal number of A's and B's. Equal number of A's and B's. So it has equal number of A's and B's. Okay, next let me define the language L3. So what do you mean by L3? L3 is equal to A power M, B power N, and N is greater than or equal to 0. N should be greater than or equal to 0. So what do you mean by that? Means at least one B should be there. Suppose, so N equal to can't be 0, right? So N equal to 1 and M is 0 means we don't have this term. So only we have B. Okay. Next, suppose A, B. Okay. And suppose A, B. Okay. Or A, B. And what else? What else strings we can have here? Then suppose now A equal to M equal to 1, B is 1. The minimum string is AB. Okay, which we already wrote here. Okay, next one is AA. Suppose both are same, BB. Okay, next AAA, double B. Okay, so AAA, double B, so on. So if you observe carefully, B is common among all the strings. Okay. Okay, how to write this one? A, we can have any number of A's, but there should be at least one B, right? So how to define this one? L3 consists of all the strings with any number of A's, followed by at least one B. Okay, so that's the definition for the language. Okay, so I hope you got all the three questions how you need to define a language. Okay, it need not to be like an exact statement, but whatever you are defining, that should be reflect to your strings. Okay, that's all about how we need to define a language. So next topic we will see about automata. Okay, so what do you mean by automata? It's if you derive in a normal way, I mean generic way, so it's an abstract model which accepts our input data and produces some output data, means some boolean expression, either 0 or 1. Okay, so these automata, what you are sending as a input means you want to read a language. Okay, so it's actually this automata, you can also call it as a language acceptor or language recognizers. Okay, an abstract model of a digital computer. So what's its function? It reads the input from the input tape. Okay, so now, so we have different automatas. Okay, so from that, first we will discuss about finite automata. What do you mean by finite automata? So it's a mathematical model which accepts a regular language. Okay, so like we are using here technical terms, technical definition. Okay, here it's a generic definition. Okay, if you see like a generic thing, then the automata is like it's an abstract model for the digital computer. It takes some input and produces some output. Okay, so actually what input it accepts means language, whether you'll see that language is accepted by the automata or not. Okay, but if you come to like technical terms, it's a mathematical model which always accepts regular languages. So what do you mean by regular languages? Okay, actually we have two different types of languages, regular language and non-regular languages. We will see this one all later. So before that, I want to introduce what do you mean by regular expression. So okay, so from this only we can derive our regular language definition. So before this, I want to discuss first what do you mean by regular expression. So that I will discuss in the next class, because I don't want to make lengthy videos. Okay, so that's it for today's class. Thanks for watching. See you in the next video. Bye bye.